Hey guys, today we're going to review something that you probably saw in Algebra 2. It's the composition of functions. So our essential question today is, how do I find a composition of two functions? And when I say a composition of functions, basically that's when you're working from the inside out. So they're going to give you two different functions and they're going to ask you to kind of put them together. So the big deal with a composition of functions is that we need to work from the inside out. So we're always going to start with the innermost parentheses, and then we're going to go from there. So there are two notations. One of them you probably will see more often, and it's the f of g of x notation, where you have the parentheses that kind of let you know, okay, I'm going to plug in g of x into the f function. The other way you could see that is they also use this open circle looking thing. So it's like f of g of x. So that O kind of stands for of. So again, that's pronounced. It's said f of g of x, just like how we used to use that f of x notation back in Algebra 1. So, oh look, there was an example on this page. Here's the example. So our first example is given us two functions. We know an f of x and a g of x, and they want me to find g of f of 3 and f of g of 3. So all I have to do here, if I'm looking, I'll first start with g of f of 3, is work from the inside out. So the first thing I'm going to do is find f of 3. So I'm going to take whatever function was f, and I'm going to plug in 3 wherever I have an x. So 2 times 3 plus 1 is 7. Now I'm going to take that number, and that's what's going to replace in here. So instead of just finding g of f of 3, I'm really just finding g of 7. I already did the inside work here. So I plug that into my g function, so x squared, 7 squared. Notice I keep using parentheses just in case my answer is negative, but g of f of 3 is just going to be 49. Okay, now if you go backwards and instead you're finding f of g of 3, the process is the same, but you have to be careful which function you're doing. So the first one we're going to do here is, whoa, I got a 0. Undo. Okay, so the first one I'm going to do here is, instead of doing f first, I'm doing the g function first. So I'm going to find g of 3 first because it's the innermost set of parentheses that I can see here. So I'm going to do 3 squared, which is 9. And then again, I'm going to plug that number in for that entire g of 3 function. So I would be finding f of 9, which is just 2 times 9 plus 1, or 19. Okay, now when you have a pair of functions, we have something called the commutative relationship. The commutative relationship is just that you can change the order of the things around. So for instance, addition is commutative. 1 plus 2 is the same thing as 2 plus 1. So commutativity is just me looking at it and saying I can do them in either order. So if a pair of functions have a commutative relationship between their compositions, then whatever I have for f of g of x is going to be the same thing as if I plugged in g of f of x. So if I look at these two functions, this f of x and this g of x, they're not commutative. I can't plug them in either way and get the same answer. So if you see that they're commutative, that means that I plug it in and I get the same thing both times whenever I plug things in. Okay, that's just kind of like a side note. Okay. For the next two problems, I want you to go ahead and on example 2, try these two right here, A and B. So pause your video, or I guess Edpuzzle is going to pause it for you, and then make sure you know how to do these. The answers right here are just going to be 1/2, and this guy is undefined because once I have 1 minus 1 on the bottom, you can't divide by 0, so there's really no point in me plugging into g of x. Okay? I guess I have it on the next slide. I don't even know what my slides look like today. Here we go. So we're using the same two functions, and instead of using numbers on the inside here, we're going to go ahead and we're using the variable. So all that means, instead of plugging in a number, I'm literally plugging a function into another function. So you're going to be plugging an expression in for the x on either of these. So for f of g of x, remember this is the same notation as saying f of g of x, if that makes you feel more comfortable. Right here, instead of using a number, I'm plugging in this entire thing, this entire function into the other function. So I have f of x plus 2. what that's going to do is wherever there's an x in this f of x function, I'm going to plug in x plus 2. So I'm going to have 1, and instead of using x, I'm using x plus 2, and then minus 1. And you can plug that in with parentheses. This one didn't matter if I plugged it in parentheses. And then I can simplify. So when I simplify, all that means on the bottom is I can combine like terms and get that that's x plus 1 on the bottom. So f of g of x, again, is just going to be another function that pops out. Same deal if I do g of f of x. Again, whatever you're plugging in, it's going to end up being an expression. So I'm going to use this entire function, this entire f of x function, and I'm going to plug it into the g function. Okay, so wherever there's an x in the g function, I'm going to plug in 1 over x minus 1. So this entire thing became that guy. Okay, so I have 1 over x minus 1 plus 2. I could find a common denominator and add them together. There's really no reason to. This is fine. The one thing here is I know here that these guys aren't commutative because I didn't get the same answer when I plugged them into each other. So like when I did f of g of x, I did not get the same thing as g of f of x. Okay, now if they ever ask you to find the domain of a composition of functions, that's what that little, I guess the graphic organizer is telling you at the bottom. In order to find the domain, remember that's the set of x values you can plug in the function. So when you're looking at this, whatever x's you can plug into your original function, that becomes the domain of that function. Then those x's become the domain of your second function, so your final function. So g of x has to be in the domain of f of x in order to use it. So yes, you can just go look at your function that you ended with. So in this case, the function I ended with is the one in the box. And the domain here, you could say it was all real numbers except for whatever made that denominator 0. So all real numbers except for -1. But we also could have looked at that and figured that out from this f of x function. Sorry. Okay, so again, you can always look at what function is there, but you also have an idea using those original functions what your domain is going to be. So in this case, it's all real numbers. X is not equal to +1 because if I plug that into the denominator, I get bad news bears. Okay, so that's the general idea of what a composition is. Again, all you're doing is working from the inside out until you get to a final answer. Have a good evening.